Okay, so let's continue for the last part for scalar product, which is how to find direction cosine and direction angle. So for direction cosine and direction angle, you have to know how to find the magnitude first. Okay, and let's see what is the direction cosine and direction angle. So here we have the direction vector of OP as AI plus BJ plus CK. So this is the point of P. Okay, represent is as ABC. So, and we have a magnitude of OP is equals to, you know the formula, square root of A square plus B square plus 6 square. And as you know that OP makes angle of alpha, which is from here to X, and beta, and we have also gamma here. So to find the direction cosine, we have cos alpha is equals to, this is the vector ABC over by the magnitude. So these are the magnitude. Okay, so just leave it the answer just like that. Okay, as you can see from here, cos square alpha plus cos square beta plus cos square gamma is equals to 1. So you have the direction cosine. If we square this, square this, square this, you'll get 1. How? Let's see. If you have cos square alpha plus cos square beta plus cos square gamma. Okay, so what's the formula for this one here? This is the formula, which is we have the vector over by the magnitude, which is in this case is the magnitude of OP. We have to square that plus, let's do for this one here, B square over OP square, and we also have C square over OP square. Okay, now let's see. If we simplify this, we have A square. These are the same thing. This one here is the same thing. So we can just take it out and we should have OP square. Okay, magnitude of OP square. And up here we have A square plus B square plus C square. So what's the formula to find the magnitude of OP? So here we have the magnitude of OP, but we have to square this. So we are going to end up with A square plus B square plus C square over by magnitude of OP. The formula is A square plus B square plus C square, and then you have a square here. So we have to square it one more time, and that will cancel out the square root. Then at last we are going to get equals to 1. So that is how we get cos square alpha plus cos square gamma plus cos square beta is equals to 1. So you have to remember this formula here. Okay, this identity here. Okay, now let's see. Now we already know how to find the direction cosine, which is we just leave the answer in term of cos. Okay, cos alpha is equals to what? Cos beta is equals to what? And let's see how to find the direction angle. So we have the direction cosine. So for direction angle, just basically just inverse cos this thing here to find your alpha, to find the angle. Okay, so notice that the unit vector, so we know that the unit vector is, let's see here, we have, let's use unit vector of OP. We write that again. OP, remember unit vector is, you have had there, so the formula is the vector over by the magnitude. Okay, so here we will have AI plus BJ plus CK over by the magnitude, which is, let's write that as OP. Okay, so now you end up with, if we separate this, we will have A over magnitude of OP I plus B over magnitude of OP B J, sorry, plus C over magnitude of OP K. Okay, and then as you can see, as you know that this is your cos alpha. Okay, your direction cosine, this one here cos alpha. So here we have cos alpha, and this one here cos gamma, and this one here is, no, this one here is cos beta, and this one here is cos gamma. So here we have a new formula, which is to find the direction, to find the unit vector. Okay, to find the unit vector for OP, we can also use this formula here. Okay, so instead of we use this formula, we can also use the direction cosine. So if the question asks you to find the direction cosine, hence find the unit vector, we can always use this formula here. So take note these two formula here. Okay, so now let's just go to the example. What is find the direction cosine of the vector OP, where P is the point 3, negative 6, 2. So obviously we have to find the direction vector OP first. So let's find that. So we have OP is equals to 3i minus 6j plus 2k. The question asks to find the direction cosine. So we have to find the magnitude first. So let's find the magnitude of OP. So magnitude of OP, remember the formula, 3 square plus negative 6 square plus 2 square. Square root everything. We have 9 plus 36 plus 4, you'll get 49. Then we end up with square root 49. You have 7 there. So how to write your final answer for direction cosine? We just leave our answer cos alpha, which is cos alpha represent this part here, equals to the vector, which is 3, over by the magnitude, which is 7. Okay, remember the formula is cos alpha equals to the vector over by the magnitude. Okay, now we continue for cos beta equals to the vector, which is negative 6 here, over by the magnitude, and then lastly cos gamma equals to 2 over 7, and this is our direction cosine. Just like that, you don't have to find the angle or so on, only if the question asks. Okay, like for example 15, find the direction cosines and direction angles. Okay, so we have to find both things. So you have the vector there, so we only need to find the magnitude. So magnitude of A equals to 2 square plus 3 square plus negative 1 square. Square root everything. We have 4 plus 9 plus 1. We have 14. Okay, square root of 14. So now to find the direction cosine. Direction cosine is just simply divide the vector with the magnitude. So we have cos alpha equals to, take 2 over this one here, 2 over square root 14. Cos beta, we will have 3 over square root 14, and cos gamma is equals to negative 1 over square root 14. So that is your direction cosine. So if the question asks for the direction angle, just simply inverse cosine these three equations here. Okay, so inverse cosine, but remember, always remember that your direction angle always in degree. In fact, for every part in this chapter 5, your calculator has to be in degree mode. Okay, so now just inverse cos alpha, we should get alpha equals to 57.69, beta is equals to 36.7, and gamma is equals to 105.5. Okay, so this one you can do it by yourself. And let's see the last example here, example 16. So here we have a vector V is inclined at 60 degree to the y-axis. So you know the angle to the y-axis, we call that as beta, like this as beta, and 60 degree to the y-axis. So let's call this as z-axis is gamma. Find its inclination. So the question asks us to find its inclination to the x-axis. So we have to find alpha. That is what we have to find. Okay, so we have beta equals to 60 degree. We have gamma equals to 60 degree, and we also have alpha that we want to find. Okay, let's try to solve this part here before we go to the next sentence. So now you know that for your direction cosine, one of the formula that we can use is cos square alpha plus cos square beta plus cos square gamma. Okay, so this is the identity that you can use. So here is one thing. So let's use that formula. So we should have cos square alpha, which we don't have, but we do have cos square beta, which is cos square 60 degree. Okay, and then we have cos square 60 degree as well is equals to 1, which we know that cos 60 is equals to 1 over 2. So we can just simplify that, plus 1 over 2 square. Here we have 1 over 2 square plus 1 over 2 square equals to 1. Okay, then we should have cos square alpha is equals to 1 over 2. So bring square to the other side, we should have cos square alpha equals to plus minus square root 1 over 2. Okay, so this is how to solve your trigonometry equation. Remember how to use LARCA. We have cos alpha equals to positive square root 1 over 2. And the other one, cos square alpha equals to negative square root 1 over 2. Okay, so just bring cos inverse to the other side. You should get alpha is equals to 45 degree, and this one alpha is equals to 135 degree, which we can conclude that V is inclined at 45 degree or 135 degree, okay, to the x-axis. Okay, now we have finished this first sentence here. So the next sentence said that if the magnitude of V is 8 units, so we have the magnitude of V is equals to 8 unit, and we have to find the vector V. Okay, so now this is one formula that we know from the direction cosine and the direction angle, which is this one here. Okay, and we can also use this one here, the unit vector here, which is cos alpha I plus cos beta j plus cos gamma k is equals the unit vector. So let's write that down. We have the unit vector is equals to cos alpha I plus cos beta j plus cos gamma k. Okay, so that is one of the formula that you have to know to find the unit vector. Okay, so we have the value for cos alpha, right? Cos alpha, which is cos 1 over 2, which is here is your cos alpha. Okay, plus minus square root 1 over 2. We do have the value for cos beta. Okay, we do have the value for cos beta, which is cos beta, cos 60 degree is 1 over 2, and we also have the value for cos gamma, which is also cos 60 degree is equals to 1 over 2. So let's write that down. We have the unit vector cos alpha is this one here, plus minus square root 1 over 2, or we can just write as 1 over square root 2, plus this one here is 1 over 2 from here, okay, cos 60 degree. Here is I, here is j, plus this one also 1 over 2 k. Okay, but now we only have the unit vector. We want to find the vector. So what is the relation between 1, 2, 3? Okay, try to remember from the previous video what is the relation between these three things: vector, magnitude, and the unit vector. Do you remember? Unit vector, besides this formula by using the direction cosine, we can also use the formula vector over magnitude to find the direction, to find the unit vector. Okay, this is one more formula that we can use to find the unit vector. Okay, so now if we rearrange that, you should get vector V is equals to unit vector times by magnitude, which is, we have the magnitude here, which is 8. Let me just write that back. We have the magnitude and the unit vector, which is our magnitude here is 8, and our unit vector is this one here. So we have plus minus 1 over square root 2i plus 1 over 2j plus 1 over 2k, and then we simplify that, we should get plus minus 4 square root 2i plus 4j plus 4k, and that's gonna be our final answer for V, which is we can just conclude V1 equals to positive 4 square root 2i plus 4j plus 4k, and V2 is equals to negative 4 square root 2i plus 4j plus 4k. Okay, so that is how we solve example 16. So what you have to know is these two formula here. Okay, make sure you know these two formula here. Get familiar with this formula, all these formulas. So here is your exit ticket for 5.1 and 5.2. Banyak sikit soalan, but it's okay, just basic question here. Okay, to make sure you understand the basic information for vectors. Okay, so I'll see you guys in the next video. This one submit on GC. Thank you, class.